In this short video, we will discuss two powerful new features released with Realflo version 7.40 and SCADApack firmware 9.9.5, run switching and PID control. First, we'll have a look at run switching in Realflo. This new tool provides you with the ability to control valves for multiple flow runs without the need to write any custom logic. A typical scenario for using run switching is that a single meter run may not have sufficient capacity or the capability to maintain high accuracy when measuring flow on a system with a very high range of flow rate. Instead, you can install several meter runs in parallel, each with a pipe diameter and meter type optimized for a specific range of flow rate. Run switching in Realflo provides a simple interface for you to enable any one or up to 4 runs. The configuration allows time for valves to swing open or closed, as well as deadband to avoid too rapid switching between runs. Here's an example of a site with 4 parallel flow runs. Each run is configured with a high and a low process value limit. The process value being monitored may be flow rate or possibly some other parameter such as pressure or temperature. When just one run at a time is open, the flow computer compares the flow rate of each run against the run's high and low set points. In this example, you can see that run 1 is for very low flow rate conditions, between rates of 0 and 4. Run 2 is configured so its valve opens at the point where run 1 reaches its upper flow rate limit, after the debounce delay timer expires. Run 1's valve is configured to close at this point. Once the flow rate rises above the run 2 high limit of 12 and stays there for more than the debounce delay time, the run 2 valve is configured to close and run 3 valve will open. Then the run 3 flow meter becomes operational and remains in use until the flow rate rises to 36. As the flow rate continues to rise, and after the debounce delay timer expires, the run 3 valve closes and run 4's valve opens. Later, as the flow rate declines below the low limit for each run in turn and stays there for, again, more than the debounce delay time, that run's valve closes and the valve to the left opens. Here's another scenario. In this case, a setting called Keep Open After Opening Next Run is enabled for each run. Also, you notice that only 3 runs are configured. Remember that run switching will work with facilities that include 2, 3, or 4 runs. In this type of configuration, all runs are grouped into a meter station, and the total station flow rate is compared against the set points for each run. Initially, as the flow rate remains between 0 and 10, only the run 1 valve is open. But after the flow rate rises above 10 and stays above it for the debounce time, the run 2 valve will open. At this point, instead of the run 1 valve closing, it remains open. Thus, the maximum station flow rate that can be measured is now the sum of the flow through both runs 1 and 2. As the flow rate continues to rise past 30 in this scenario, the run 3 valve is configured to open. Now all 3 runs are in use, allowing measurement of much higher flow rates. You can enable run switching in the Flow Computer Setup dialog. Set the number of run switching groups to 1. Future releases of Realflo may allow more than 1 group. Once run switching has been enabled, you configure it by double-clicking Switch Group 1 in the configuration tree. You can rename the switch group by editing the ID if desired. The run switching mode is by default set to Monitor Last Opened Run, in which case decisions are based only on the flow rate of the most recently opened run. However, you can set this to Monitor All Runs if you choose the option Keep Open After Opening Next Run on the Switched Runs tab. Or perhaps if you want to monitor a primary variable other than flow rate. DO mode selects whether 2 digital outputs are used to control the valve, open and close separately, or if a single DO controls the valve's state. Switch delay sets how long the flow computer will suspend monitoring of the flow run as its valve is configured to open or close because the flow rate will be changing rapidly. This is the time required for the valve to swing fully and the flow to stabilize. And debounce delay is the duration that the flow rate, or other primary variable, needs to stay above the high set point or below the low set point before run switching is initiated. After configuring the group settings, selecting the Switched Runs tab takes you to a dialog where each run to be included in the system is configured. First, enable the required run. and select that run's name. Next, enter the 6-digit Modbus address of the primary variable to be monitored. This is likely to be the run's flow rate, but again, it could be another variable. Enter the high and low limit values next. These need to be carefully selected based on the site's actual requirements. Energize to open is normally enabled, but can be disabled if you need to reverse the action of the open and close digital outputs. And here is keep open after opening next run, which allows multiple parallel runs to operate at the same time, adding their flow values together. And then you specify the digital output object names used to directly control the valve position. Finally, carry on to configure the other runs to be included in the system. Once the configuration is complete and the site is operational, you'll want to monitor the operation of the run switching system. In the View menu, select Run Switching Readings, which takes you to this display. Click the Update Readings button to go online with the system. Runs that are included are shown as enabled, though you'll see Focus for the currently active or open run. The run's name and its current flow status are displayed. Flow state may be opened or closed, or if in transition, it may be opening or closing. The run's current flow rate or other primary variable is displayed here. Remember that if Keep Run Open is enabled, more than one run may be open and flowing. The current open and closed digital output states are also shown. Next, we'll have a look at PID control in Realflo 7.40. The new PID control capabilities of Realflo can support up to 8 PID loops without the need for you to write any logic at all. This can significantly reduce the time and cost required to develop an application. Each PID loop is highly configurable through the use of straightforward dialogues. The PID loops can easily interface with remote connect objects and logic through the object database. The control output may be either an analog value, similar to the PID-A block in Telepace Studio, or digital outputs, similar to the PID-D block. Each PID loop has an optional override subloop that can take control under exceptional circumstances. The override subloop has its own process value and setpoint. With this new capability, PID loop control, tuning, and monitoring are all done through Realflo. To enable the PID functionality, open the Flow Computer Setup dialog, then select the number of PID loops you require. This can be changed later and may be configured for up to 8 loops. After you set the number of desired PID loops, configure each loop by double-clicking on it in the configuration tree. First, you enable the loop, then set the control mode. This would normally be auto mode, but can be changed to manual when you need to manually adjust the output. This may be when first starting the PID loop or for maintenance purposes. Loop control type lets you specify only a primary loop or primary with override. An override loop can take control under exceptional circumstances. For example, the primary loop might control flow rate, but the override loop might control pressure and take control when the pressure rises too high. Loop period is the time between PID calculations, and override type is used when the control type is primary with override. If set to high, the RTU enables either the main or override loop, depending on which loop's absolute calculated change value is greater. Or when set to low, it selects the main or override loop, depending on which loop's calculated change value is less. The Input tab is where settings unique to each of the primary and the override loops are configured. First, you specify the Modbus register containing the process value to be monitored. Then you enter the highest and lowest allowable set points. The set point mode will most likely be configured as Object, allowing you to change the set point through a database object, or it can alternately be set to Local, in which case the set point can be manually entered. And the ramp rate specifies the rate at which a new set point will shift to the new value in units per minute. This helps to avoid dramatic bumps in the process. The Output tab is where you'll configure parameters for the PID loop output. The output type might be analog output, in which case the calculated output drives an analog object, or it might be digital output, in which case the output will drive 2 Boolean objects. Finally, you specify the upper and lower limits of the output value. The Tuning tab is where you'll adjust the gain, reset, and rate of the loop, including the override loop, if one has been configured. Deadband for each loop specifies the amount the process value needs to change before a new output calculation is done. Override threshold is used to help prevent premature selection of the override loop. And if you set the loop control mode to manual, you'll enter a new manual output value here before writing it to the loop. Once you've configured PID control in Realflo, you can monitor loop activity by selecting PID loop readings in the View menu. Here, the primary loop set point and process value are shown. Numerous other helpful items are also shown. The same details are also shown for the override loop. And you can also see which loop is currently active and the live output value. To learn more about Remote Connect and the SCADA pack, access the user documentation on the Schneider Electric website. Also, see our other videos on YouTube.